access often starts simple and then quietly turns into a tangle of accounts, roles, and exceptions. A few projects become dozens, more teams join the platform, and soon nobody is quite sure who can touch which database or destroy which environment. You are listening to a Tuesday Insights feature from Bare Metal Cyber magazine, developed by Bare Metal Cyber, focused on making that situation more understandable. The topic is Cloud Identity and Access Management, Cloud IAM, and the goal is to give you a clear mental model for how it works, where it fits, and how least privilege can make sense even at scale. Cloud IAM is the layer in your cloud that decides who or what can do which actions on which resources. It combines people identities, service identities, roles, and permission policies into one decision engine. It is not just another product logo. It is a pattern that almost every major cloud provider implements in its own way. At the identity and authorization layer, it touches people like engineers and support staff, machines like serverless functions and virtual machines, and data such as storage buckets and databases. It is different from single sign-on, VPNs, and traditional directory services, even though it often uses those as sources of truth. Cloud IAM is both technology and process. The technology is what you see in each provider's console and APIs, the panel where you assign roles, the place you define policies, the hierarchy of organizations, folders, projects, or subscriptions. The process is how your organization decides which roles exist, how they map to real job duties, how environments are separated, and how access is reviewed over time. When teams focus only on the screens and ignore the process, permissions drift away from reality, and small exceptions slowly turn into systemic risk. At a high level, Cloud IAM works by evaluating each request against identities, roles, and policies. A user opens the console, a script calls an API, or a pipeline runs a command, and the platform first checks which identity is making that request. That identity might come from single sign-on, from a built-in service account, or from a workload identity tied to a compute service. The platform then looks at the roles or policies attached to that identity on the target resource and decides whether the requested action is allowed or denied, recording the result in logs. The building blocks are simple to describe. You have identities that represent people and services. You have roles that bundle individual permissions into something reusable. You have bindings or assignments that attach roles to identities on particular resources or groups of resources. On top of that, some platforms let you add conditions, such as time of day or source network, and all of this sits inside a hierarchy of organizations or management groups. The complexity comes from how these pieces combine at scale, not from the pieces themselves. Imagine a small example. A developer signs in to the cloud console through single sign-on and lands in a non-production project. Their corporate group membership maps to a developer role that allows them to create and manage certain resources in that project, but not in production. When they try to spin up a virtual machine, the platform checks their identity, finds the role on that project, looks at the permissions in that role, and compares them with the requested action. If the create permission is present on that resource type, the request is allowed and locked. If not, it is denied with a clear error. The same pattern applies to pipelines deploying infrastructure as code, serverless functions reading from storage, and support tools querying logs. Cloud IAM quietly assumes a few things that are easy to overlook. It assumes that your upstream directory has clean identities, that group memberships map to real responsibilities, and that your resource hierarchy is reasonably well organized. It assumes that logs are collected and retained so you can trace who did what, and that someone actually reviews access patterns and corrects them. When those assumptions do not hold, the engine still makes decisions, but they may not match what your organization believes is happening, and that gap is where surprising access paths emerge. In everyday work, Cloud IAM shows up every time a person or service needs to touch a cloud resource. One common pattern is separating development, testing, and production environments so that the same person does not have broad write access everywhere. Teams define roles that are scoped to specific projects or subscriptions, with stricter permissions in production and more freedom in non-production. That way, engineers can experiment and move quickly in safe spaces while keeping the blast radius smaller in the systems that actually serve customers. A practical quick win is taming long-lived admin roles. Many environments start with a handful of users who have owner or administrator rights across large swaths of the estate and never revisit those rights. With Cloud IAM, you can replace that pattern with narrower roles for daily work and just-in-time elevation for higher-risk tasks. A small team might begin with a single critical subscription, identify who truly needs broad powers, and move those users to limited roles, plus time-bound, audited elevation paths and a clearly documented break glass account. That shift alone reduces standing privilege without blocking essential operations. As organizations mature, Cloud IAM becomes a backbone for more strategic patterns. It can enforce separation of duties between teams that write code and teams that operate production. It can support multi-tenant architectures by ensuring each customer's resources are only reachable by the right identities, including internal support roles. It can also reinforce governance by centralizing sensitive actions, such as network configuration or key management, into dedicated platform teams. Over time, practices like pipelines deploy while humans inspect, or support can read but not change production, are encoded directly into the roles and policies. Cloud IAM also has a useful role in hybrid and multi-cloud setups. Identity may originate from a central directory, and applications may span data centers and multiple providers, but each cloud still has its own guardrail layer. In these cases, teams map central groups into cloud-specific roles and rely on the cloud decision engine as the final check before a resource is touched. When something goes wrong, that consistent pattern makes audits and incident investigations much easier because access paths are visible instead of scattered across one-off configurations. When designed thoughtfully, Cloud IAM delivers real benefits. It centralizes access control so that questions like, "Who can delete backups for this database?" have clear answers. It gives security, platform, and audit teams one place to understand how identities and permissions relate. It also makes least privilege more practical because you can align roles with real job duties and reuse them instead of crafting one-off permission sets for every individual ticket. That central model supports faster troubleshooting and more confident change because teams know where to look. The same system can become a source of friction if it grows without a plan. Fine-grained permissions, deep hierarchies, and dense policy languages can lead to confusion and fear of change. Roles pile up with names that nobody understands. Overlapping policies create surprising effects, and exceptions get added as quick fixes and never removed. Engineers need enough skill to reason about inheritance and the meaning of a single permission across multiple services, which takes time and practice. When that skill and clarity are missing, the default answer becomes, just give them more rights so they can work, which quietly erodes least privilege. Trade-offs also appear in how organizations structure control and speed. Strong central control over Cloud IAM can reduce risk but slow teams down if every small change requires a ticket and days of waiting. Fully decentralizing control can feel fast, but often leads to each team inventing its own pattern, making the environment hard to audit or repair. A healthy middle ground usually involves a central group defining guardrails, standard roles, and good patterns, while application teams manage day-to-day access within those boundaries. In practice, you are dialing between visibility, control, and speed, rather than maximizing all three at once. Common failure modes tend to follow a few themes. One is the "it works, ship it" approach, where permissions are widened just enough to stop error messages and then never revisited. Over time, generic admin roles spread, powerful service accounts accumulate, and nobody wants to touch old policies for fear of breaking production.
Another is designing roles around individual people rather than job functions. When that happens, every change in responsibilities leads to one more exception, and joiner, mover, and leaver workflows become fragile and slow.
Shallow adoption of CLOUADI also shows up when it is treated as a one-time project. Teams import users from a directory, create a few default roles, and assume the work is done. Without regular access reviews, clear ownership, and feedback from incidents and audits, the model drifts. Permissions exist, but decisions about access still happen in chat threads and side conversations instead of being grounded in the design. Dashboards may look impressive, but they do not change how people request, evaluate, or revoke access. Deep adoption looks different in daily behavior. Access requests refer to known roles, such as a production read-only role or a support investigation role, rather than asking for generic admin access. Service accounts have focused permissions, clear owners, and names that reflect their purpose, and they are retired when applications change. Platform and security teams can answer basic access questions using the configuration itself, instead of piecing together logs and tribal memory. That is often the moment where Cloud IAM moves from a checkbox to a backbone. Healthy signals appear in metrics and review outcomes. You see fewer permanent administrator assignments and more use of scoped roles with just-in-time elevation when needed. Access reviews result in real removals and corrections instead of rubber stamp approvals. When an incident involves unauthorized or unexpected access, the outcome is a targeted change in roles or policies that is understood by the teams involved, not a panic-driven clampdown that nobody can work with. People still bump into access denials, but those denials are understandable, fixable through known paths, and sometimes reveal genuine gaps before they cause harm. At its heart, Cloud IAM is about making access to cloud resources explicit, understandable, and adjustable over time instead of accidental and undocumented. It takes identities, permissions, and resource hierarchies and turns them into a model that humans and tools can reason about together. When that model aligns with real job duties and real architectures, least privilege becomes something you can approach step by step rather than an abstract slogan. A useful question for any environment is whether the current access design actually reflects how teams work today. If the honest answer is that it only partly does, that gap is a clear starting point for improvement. Even small moves, such as taming admin roles in one critical subscription or standardizing a small set of well-designed roles, can make Cloud IAM feel less like a source of anxiety and more like a foundation for safer growth in the cloud.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.